Hey everyone, welcome to part 2 of our trinomial factoring video. So after all that factoring, the next logical question is, how do we know if a trinomial is factorable? Is there a potential that we're given a trinomial that cannot be factored? And the answer to that question is yes. So then how do we know? Well, if we try to factor something like x squared plus 5x minus 9. So leading coefficient is 1, constant term is negative 9. So 1 times negative 9 is negative 9. So we'll list out all our possible factor pairs. So we have 1 and negative 9, 3 and negative 3, and negative 1 and positive 9. Okay. Well, looking at all of these factor pairs, none of these add up to positive 5. So that's an issue. We can't use grouping. So then maybe this trinomial can't be factored. Well, how do we know for sure though? Well, the standard form of a quadratic expression is ax squared plus bx plus c. So a is the coefficient of the x squared term, b is the coefficient of x, and c is our constant term. We can calculate something called the discriminant of a quadratic, which is equivalent to b squared minus 4ac. And once we find that value, if and only if the discriminant is a perfect square, then the trinomial is factorable. Okay, so let's say we're looking at a hard problem and we just can't come up with a factor pair and we want to write not factorable. Well, before we do that, it's always helpful to check the discriminant to know for sure. So let's look at doing that in this example. Okay, so a is 1, that's the coefficient of x squared, b is 5, the coefficient of x, c is negative 9, and we're looking for capital D, which is the discriminant. So in order to do that, we're going to do b squared minus 4ac. Okay, so b is 5 squared minus 4 times a times c. So this is going to be 25 minus 4 times 1 times negative 9 is negative 36. So we get 25 plus 36, which is 61. So the discriminant is 61. Well, if we know our perfect squares, 61 is not a perfect square. So not a PS, perfect square, I'll abbreviate. So that tells us that our quadratic is not factorable. Okay, so this actually means that the quadratic is prime. So just the same way that 7 only has factors of 1 in itself, this quadratic, this trinomial, only has factors of 1 and itself. Right, and now we have a concrete way to know if a trinomial is factorable or not. Right, if this is a perfect square, we can factor it. If it's not, then we cannot factor it. The other nice thing about the discriminant, it's going to show up later. So if we understand the discriminant now, it makes the topic later that much easier. So find the discriminant of each of the following polynomials to determine if it can be factored. If it is factorable, then factor the polynomial. So first up, x squared minus x plus 4. So let's list out our a, our b, our c, and the discriminant. So the coefficient of x squared is 1. Coefficient of x is negative 1. C, the constant term, is positive 4. So our discriminant, I'll write it up here just so we can reference it, is b squared minus 4ac. So we have negative 1 squared minus 4 times a times c. So negative 1 squared is positive 1 minus 4 times 1 times 4 is 16. So our discriminant is negative 15. Well, that's perfect. Negative number cannot be a perfect square. Right? So this is not a perfect square. So that means that the trinomial is not factorable. All right, our next example, x squared plus 3x minus 28. A is 1, b is 3, c is negative 28. So we have to find the discriminant. So b squared, so 3 squared, minus 4, a, c. So we have 9 minus 4 times 1 times negative 28 is going to be 80 plus 32, so negative 112. So that's 121. So this is a perfect square, which means we can factor the trinomial. So let's try to factor this. So our factors would start with x. So we need factors of negative 28 that add to positive 3. Okay, well, negative 28 means one factor is positive, one factor is negative. We're adding to a positive number, so the larger factor will be positive. So let's see, 7 and 4 jump out. 7 would be the larger factor, 4 would be the smaller factor. So let's see, we'd have 7x minus 4x, which is 3x. So perfect. X plus 7 and x minus 4 are the factors of x squared plus 3x minus 28. Now, what happens when our trinomial has both an x and a y in it? Like x squared plus 2xy minus 3y squared. Well, let's look at a problem without the y in it first. So let's look at x squared plus 2x minus 3. If we were asked to factor that, our factors would start with x. And we need factors of negative 3 that add to positive 2. So there's going to be a positive factor and a negative factor. The larger factor is positive. And 3 only has 2 factors, 1 and 3. So 3 and 1, let's just verify 3x minus x. Perfect. Okay, so going back to the original problem they gave us, so we have x and x. How does the y change it? Well, when we multiply 3 times negative 1, we need negative 3y squared, not just negative 3. So what we're going to do is make this plus 3y and minus y, and if we distribute, we get 3xy minus xy, which is 2xy, and then 3y times negative y is negative 3y squared. So essentially, we can factor this as if the y wasn't there, and then we put the y into the second term, so that our multiplication, our distribution, would give us the polynomial we were given. Okay, so let's look here. So our factors are both going to start with x. So we need to factor, let's see, multiply to 30, add to negative 11. So multiply to a positive number, add to a negative number, so both factors need to be negative. So let's see, factors of 30 that would add to negative 11. So negative 6 and negative 5. We'll make it negative 6y and negative 5y. Negative 6y times negative 5y is 30y squared. Perfect. And if we do our distribution, we'd have minus 5xy minus 6xy, which is minus 11xy. And again, I'll leave that exercise for you to work through on your own. Last one, if the factors of x squared minus 17x plus 70 are x minus 7 and x plus k, what is the value of k? So essentially, they're asking us to factor x squared minus 17x plus 70 and find out what the factors are. And they actually helped us out because they told us what one of the factors is already. So again, we'll start with x squared minus 17x plus 70. So our factors would start with x. And even more so, we know that one of the factors is x minus 7. So let's think. Factors of 70, where one of them is negative 7, so that would be negative 10. And if we distribute, do we get negative 17x? So we get negative 10x minus 7x, which is negative 17x, so perfect. Now they told us that it's x plus k. So if we rewrite this factor with an addition sign, it'd be x plus negative 10. So that means that k equals negative 10. Okay, so biggest piece from this video is the discriminant, b squared minus 4ac. If we're ever working through a problem and we just can't seem to find that factor pair, check the discriminant, because it will tell you if you should keep working or maybe the trinomial that you're given is not factorable. And then we round it off with a few more examples, such as trinomials with both x and y in them, and this k-value problem, which when we first read this problem seems really challenging, but it's actually easier than factoring because they gave us half of the factor, or they gave us one factor out of the two. Okay, so now continue to practice with your factoring, practice your grouping method, practice your guess and check, go through finding the discriminant, and become an expert at factoring trinomials with a leading coefficient of 1. And once you've mastered that, head over to the video to learn how to factor trinomials where the coefficient is not 1. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.